Now, this shell expansion plan is basically this kind of plan where your 3D effect is made into 2D. That means your plan, half of the ship, right from the bottom, you can get in the plan. This is bottom half you're getting in the plan plus the top half. The hull part also you're getting in the shell expansion plan. Now, why it is known as shell expansion plan? Because the hull is exposed right from bottom half till the top half. It's showing all your strakes. What are strakes? Strakes are longitudinal strips of plating which are joined by your butt welding and seam welding, and they form the part of your ship's hull. So this is the keel plate. It's even thickness right from forward to aft. There is no change in thickness of the keel plate. It's the thickest plate. Then you have bottom plating, which is known as garboard strakes. So these are the bottom strakes which are marked A. These are the garboard strakes. And then you have the bilge strakes, and on top you have the shear strakes. Now the letters start from your keel to top, and the numbering is done from aft perpendicular to forward. But here, if you see, we omit I and O in the letters in the shell plating. Any reason why do we omit I and O in the lettering? Why do we omit I and O? किसी को पता है? ये तो कॉमन क्वेश्चन था ओरल्स का सेकंड मेट्स का. किसी को नहीं और 1 लिखो कंफ्यूज हो जाओगे. सिमिलरली 1 and 0 में कंफ्यूजन हो जाएगा. O जो है 1 0. जो shell expansion plan is a 2D model or 2D drawing, not 2D model, but 2D drawing of a 3-dimensional surface of ship's hull and developed from ship's lines plan. So your lines plan make up your shell expansion plan with the contour lines erected straight on the baseline representing the ship's length. Now, this is a very basic plan which I've shown, but on your ship, you'll have the frame numbers, everything written there, thickness of the plating also. So the plan shows your seams and butts. Seams are basically horizontal welds and butts are vertical welds, plus your thicknesses of your plating, plus what frame numbers are there, that will be mentioned. And the arrangement basically is taken from 3D model, is represented on a 2D drawing, which is a shell expansion plan. So all your vertical dimensions of this drawing are taken from the girth of the vessel. Girth means the thickness of the vessel, rather than being on the direct vertical projection. So here you are seeing the bottom and side as a continuous fold. You don't have it separate, but you have it as a continuous fold. You're seeing the bottom half and the top half as a continuous plating. Like you have these various plating, but normally you can just see the top, you can't see the bottom. So the typical shell expansion plan here, this one is a tanker which is showing your numbers of the plate and letters of the plate strake. And now when the strakes run out, the girth, basically thickness, is decreasing towards the forward and aft region. So as your block coefficient is less, your girth decrease becomes more. Like on VLCC, your block coefficient is 0.85. So your girth decreasing will be less because the curve becomes just at the ends. So here, basically with the shell expansion plan, you know where your plating is damaged, which one is to be repaired, what is the thickness of plating, how much steel will be required. So everything you get from your shell expansion plan. So basically the thing is prefabrication becomes an accepted practice, and any shell expansion plan drawing produced will generally have the numbering system related to the erection of fabrication unit rather than individual plates. So that is what you have to note. So single plates are often marked in sequence so that you can do the ordering and product identification when you have the shipbuilding done. So we need to count the plates in 2D. One is athwartship and other is forenav. So we use half-width diagram to check the position of the strake because you have symmetry on port and starboard side. So the keel strake is in the center line, half on the port side, half on the starboard side. Next is your garboard strake, which is marked as A. So as I said, those plates which two join to one are known as stellar plate because you're stealing the plate. That's a stellar plate when you two plates join to one. And if two do not join to any other, you don't have a new plate, that is known as a drop strake. So the strakes that do not run the entire length of the ship or the ship's hull decrease at the ends, and there are no strakes here which you have in the aft region. While the stellar plate will be in the forward region, aft region, as well as bottom region, wherever the curve is. So suppose your vessel basically is here, so your stellar plate will be in this region. Wherever the curvature is reducing, you will have stellar plate and the upper. While the drop strake will only be in these regions or in the distance, but they'll not be in all regions, because two plates, you have plates, you're not making into one plate. That is drop strake. But if you have maybe two strakes joining to one, that becomes your stellar plate. So this is a drop strake, which is basically was supposed to be there, but it's not there. But when two join to one is known as stellar. So the top strake is the shear strake, not the fish plate, but the shear strake. And the welding which is done horizontally are seams, and the welding which is done vertically is known as butt. So the girth of the ship decreases towards the ends, and so the width of the plate must be decreased in these parts. To save the making of the plates too narrow at the ends, it is usually a number of run of pairs of adjacent strakes into one. Here you have the stellar plates. So we're talking about strakes, not plates. Garboard strake is known as strake A. Next to strake A is B strake. The numbering continues till shear strake. So the plates are counted from aft to forward. So drop strake is a strake that terminates towards the stem or the stern of the ship because of the ship's decreasing girth, and that has to be eliminated at the bow and stern to reduce the amount of plating. Garboard strake is the first strake on either side of you have the keel, the B strake, C strake, bilge strake, E strake, F strake. This is the shear strake. This is the deck stringing. These are the deck girders. These are the bottom girders. Now, what can AH4 represent? What can AH4 represent? Any idea? And try out. और 4 है numbering from aft. Steel को H बोलते हैं. का H high tensile steel or number 4. It can be either garboard strake or it can be grade A steel. So grade A steel or garboard strake, A, H becomes high tensile steel, and 4 is the numbering from.
Hello friends, in this tutorial video, I'll explain the procedure to create a three-dimensional model of this boat using AutoCAD software. We have, in fact, 3 different options to create a 3D model using AutoCAD software. We have solid, surface, and mesh modeling techniques. In this tutorial, I'll make use of the mesh modeling technique, using which we will create the hull shape of this boat using the EdSurf command in the primitives panel. Using this command, we can create complex surfaces and produce interesting results. Please refer my tutorial on creating a 3D curtain if you don't have a basic idea on EdSurf command. I have provided the link in the upper right corner of the screen. Please go through that video before exploring this tutorial. So let's get started. Let me switch over to the top view. When you look at the shape of the boat in the top view, you can see that it's symmetrical about the horizontal as well as about the vertical axis. So instead of creating the entire model, I'll create just quarter portion or 1/4 of it. Then I'll give mirror command to generate the entire model. I'll start by creating this particular profile first. So I'll open a new file. I'll turn off the grid. You should make sure that the 3D modeling interface is active. Now I'll start a polyline from this particular point. Now I'll right click to go to arc option. I'll right click again. Then I'll select second point and I'll pick a point somewhere over here. Then I'll pick this particular point. Then again. Now I'll just come back to the line mode. Right click and choose line. Activate the ortho mode on. Then I'll pick to define the endpoint of this polyline. So this is my first profile. Now I'll switch over to the southwest isometric view. Then I'll change my viewport configuration by clicking on this hyphen sign over here. Then I'll choose 3 left. When you take this configuration, you will get a major viewport on the left side and 2 smaller viewports on the right side. Next, I'll create the profile of the boat as you see from the front side. So I'll generate a front elevation in this viewport. So just click here and choose front. Then I'll create another polyline starting from this endpoint. Then turn off the ortho mode. Then go to right click and choose arc option. Then right click again and choose second point. The reason why I go for second point is to guide the curvature of the arc through my desired location. So I want this arc to come through this particular point. Hence I'll get a better control over the shape of the arc. Then pick to define the endpoint, and this arc is pretty okay, so I don't have to change the curvature, so no need to go to second point option. We can pick to define the endpoint here. Then I'll switch over to the line mode, so right click, choose line. Then I need a point corresponding to this right underneath, so just track to get that point. So I'll just keep my cursor over here, then activate the tracking. You can press F11 function key if the tracking is not active. Okay, now I'll just pick to define it. So that profile is also defined. Next, I'll create a third profile connecting these two endpoints. Okay, for that, I'll generate a left side elevation in this viewport. So this particular profile corresponds to this profile which you see on top, and this vertical line corresponds to this profile which you have drawn just now. Next, I'll go to polyline again. Now I'll start a polyline exactly from this endpoint. Now I'll activate this viewport. Now I would like to draw a line segment. So activate the ortho mode on, then just pick a point somewhere over here. That's a straight segment. Then you go to arc option, then turn off the ortho mode. Then you go to second point because I want to control the curvature. I'll pick a point somewhere over here, and you can pick an endpoint here. So this is the third profile. Now these three profiles define 1/4 of the shape of the hull of the boat. Next I'll create an edge served mesh connecting these edges, but the edge serve command needs 4 edges. We have created only 3. So using the break command, you can split any of this edge into 2 edges so that you will get altogether 4. So I'll give break command. You can type the letter BR for break. So it'll ask you to select object. I'll just click a point somewhere over here. So in the break command, when you select the object, you not only select the object to be broken, but you specify the first breakpoint. Now it will ask you for the second breakpoint. I want the second breakpoint to be the same as the first one. So you can use the shortcut key @ sign, because AutoCAD interprets @ as the last point. So just type @ and give an enter. Now when you click over here, you can see that this particular segment is broken at this point, and hence altogether you have 4 edges. Next I'll click on Mesh tab. Then I'll click on the edge serve command. Now it will ask you to select the first edge, second edge, third edge, and the fourth edge. It has created a mesh, but it's almost segmented. When you go to shaded representation, you can see that it's segmented. Okay, you have to increase the number of faces in this mesh. So I'll undo the edge serve command. Now we have 2 variables in mesh modeling which controls the density of mesh, or the number of faces generated in the horizontal as well as in the vertical direction. The number of faces generated in the horizontal direction is controlled by the surf tab 1 variable. So I'll give surf tab 1 and I'll give the value 25. Then I'll go to surf tab 2 variable which controls the number of faces in the vertical direction. Then I'll give the value 25. Okay, now I'll repeat the edge serve command. I'll select the first edge, second edge, third edge, and the fourth edge. Now it's a smooth mesh. Next I'll switch over to the single viewport configuration. Okay, now I'll go to the plan view. Next you can mirror this quarter portion of the mesh to generate the entire hull of the boat. So I'll go to mirror command and I'll select the entire set of objects using a standard window, and this is my first point on the mirror line, and this is my second point on the mirror line. Next I'll repeat the mirror command. So right click and repeat mirror and select the entire objects. And this is the first point on the mirror line. Now second point on the mirror line you can pick over here. Now it's a perfect vertical axis. Just go to southwest isometric view and see the shape of the hull of the boat which you have created. Change the display representation to realistic and you can see what you have done. It is an exact shape of the hull of a boat. Next I'll create a border on top. In order to create this border, I'm going to make use of the profiles which we have already created. But while you work with these profiles, these meshes might interfere with your object selection. So I'll erase these meshes for the time being using the erase command. Then I'll go to join option, go to modify panel and just click on join. Then you select all these profiles using a crossing window. Okay, just give an enter. Now you can see that it's a single profile. Next I'll give an offset. And I'll give an offset distance by picking 2 points because I've drawn everything without giving any dimensions. So I'll just pick 2 points to specify the offset distance, and the distance between these 2 points will be taken as that distance value. This is the object offset and pick a point on this desired side. Next, I'll apply press pull command between these two profiles to create a surface from here. So I'll just move my mouse slightly in the upward direction and I'll pick a point here. So that distance will again be taken as the height of extrusion. Next, I would like to get those erased meshes back. So you can give the command for that. Because you know those the most recently erased set of objects. But if you erase a set of objects with the intention to get these objects back using the command, you should not erase any other objects while you work. Next, I'll create these cross members which you see over here. But before you
Did you know that animals listen to dominating tactics because they're scared? If you want to have a mindful relationship with your animal, then you might want to watch this video. In this video, I'm going to share with you the mindful approach that you can start using today to develop a strong relationship between you and your animal.
But before you create the cross members, you can erase the meshes just as we have done before. So I'll go to erase command. When I'm asked to select objects, you don't have to select these meshes again. Instead, you can use the shortcut key P. P stands for previous. AutoCAD memorizes the previous selection. So I'll erase it. Next, I'll change my display representation to 2D wireframe. Then I'll create a rectangle with this particular point as the first corner. Then I'll simply drag to specify this nearest point as the second point. I'll change the display representation back to realistic. Then I'll extrude this rectangle, okay, through a small distance. It should be slightly below the extrusion of the border which you have done before. Okay. Next, using the array command, I will generate multiple copies of this. So I'll click on rectangular array, select this object, then you can go to the row option. I need only a single row. So I click on rows and give the value 1 for the number of rows. Then you can just give an enter and give one more enter. Now click on the array object and you will get a ribbon which represents all the parameter corresponding to the array. I need say 9 columns. Then the distance between individual column I'll make as say 640. This is just a random value. Now you can see that you have got more numbers, so you can reduce the columns to 7. Okay, you can just close the array. Now you can again make use of the command to get those erased meshes back. Now you can give a proper color. But before you give a color, you have to explode the array object, because you know that array object will remain as a single unit, and only if you explode it, you will be able to change any property related with the array object. So I'll give X command for explode and just give an enter after selecting the array object. Next, I'll select this entire object using a standard window. Then I'll press Ctrl 1 to get the properties panel. Then I'll choose this particular color 23 or any desired color of your choice. And hence we have completed the 3D model of a boat. Hope this tutorial was interesting and you have got a number of useful information related with mesh modeling. That's all about this tutorial. Please hit the like button below this video if you liked it and subscribe to my channel. Until I catch you in the next tutorial, bye and take care. Thanks for your time.
So that was your CAD CAM, this modeling of 3D and wireframe and solid frame modeling. The next class we'll be doing your past papers. One thing remaining is your prefabrication that I'll be doing in your, after the past papers have been completed, then we'll start with your prefabrication and other topics. For 2 minutes, let's see if we can not stress you with past papers now. The next class we'll start with the past papers. We can have a break now.